Let's continue our unit on ratios and proportions and take some time to talk about unit rates. Rates are used to describe how quantities change when we're looking at different units for the numerator and the denominator. Example, miles per hour will have different units, miles and hours, which represents distance over time. Price per unit, the total price divided by the number of units purchased, will give us a unit rate. So for example, the unit rate, a train traveled 120 miles in 2 hours. What is the average speed of the train in miles per hour? And so our unit rate wants us to find out how many miles were traveled in just 1 hour, and that's how we get speed, many common unit rates. So what we do is we look at our proportion, our ratio, and we know that we're comparing miles to hours, and our original ratio is 120 miles in 2 hours. So to get a unit rate, we just need to simplify completely so that the denominator is just a 1. So whether or not it divides evenly or simplifies evenly, we need to make sure the denominator is 1. So we always just divide by the denominator. Okay, or we're dividing the numerator by the denominator. So we can do 120 divided by 2, and we get 60 miles per 1 hour. 60 miles per hour. Then what we can do is use this unit rate in order to answer another question. How far would the train travel in 5 hours? Well, if it's traveling 60 miles per, let's say per 1 hour, we can look at our proportion and say, okay, well, how many miles in 5 hours? That's just a simple multiplication. 1 times 5 and 60 times 5 gives us our new rate. So we end up with 300 miles in 5 hours. So let's go ahead and do a couple examples where we apply a unit rate. Tony buys 6 large pizzas for $77.94 before tax. We want to find the price for a single large pizza. So we're looking at price per pizza. It often helps to write out what the ratio is comparing, or the rate is comparing as units, and then start filling in information, but we need to make sure we can clearly visualize what that relationship is. So it's $77.94 for 6 pizzas. And so we can do that division, which gives us $12.99 for 1 pizza. So the price is $12.99. Then we can find the price of 10 pizzas. We just take the $12.99 and we multiply it by 10 to get $129.90 for 10 large pizzas. 36-inch tires on a truck have a circumference of 9.42 feet. To the nearest whole rotation, how many rotations must the tire make for the truck to travel 2 miles in a straight line? And so we want to think about it. We're comparing rotations to distance. Okay, so we are comparing rotations to distance. Okay, we need to think very, very carefully about that. Okay, rotations to distance. Now we know that one rotation is a circumference of 9.42 feet. So we need to figure out, to nearest rotation, how many rotations must the tire make for the truck to travel 2 miles in a straight line. Okay, so then we want to set up our proportion and look and see. All right, well, we have, actually, before we do that, let's go ahead and rewrite this as a unit rate. Let's actually flip these, and let's do distance to rotations. Distance to rotations. That way we actually have a unit rate. 9.42 feet per rotation. All right, so now we need to figure out, okay, if I want to travel 2 miles, well, 2 miles is 2 times 5,280 feet, because 1 mile is 5,280 feet. So we go ahead and do that multiplication, and we get 10,560 feet. So now we have our proportion here. We've got 9.42 feet for one rotation, and we want to figure out how many rotations we get for 10,560 feet. So we just do some cross multiplication for solving. Okay, so we have 9.42 feet. We can get rid of our units. 9.42x equals 10,560. Divide both sides by 9.42. And rounded to the nearest whole rotation is 1,121.